Hi dear parents, welcome back to another math hour. Today I'm just going to show you how to add and subtract radicals, also known as square roots. Okay, so let's start with an example right over here. This is the square root, also known as radical, 25. As the kids know, the square root of 25, this is a perfect square root, meaning that there is an answer to this, and that answer is 5, because 5 times 5 is 25. Okay, that's easy enough, but we'd like to learn how to add and subtract radicals, or square roots, that are not perfect. So let me delete this right now. We don't need perfect square roots. We want to work with square roots like this, 13. Radical 13, or square root of 13. We want to add this, or we want to subtract this. How do we do that? Let me show you an example right here. Let's say square root of 13 plus square root of 13. Okay? How do we do this? Well, first thing you have to understand is that when you are adding and subtracting radicals, the terms, that means the numbers inside the square root, matter. They have to be the same. Okay? When we say same, I mean like terms. I'll write it down for you guys right now. They have to be like terms. In other words, same number if you want to add or subtract a radical. Alright, let me make this a little bit smaller. There we go. As you can see, radical 13 are same. We can do math with this. So that means I will definitely keep radical 13 or square root of 13 in my answer, my final answer. However, we are not done yet. All the kids know that in front of every single radical, right here in front, is a coefficient. In other words, there's a number. And if there's no number in the front, automatically you have to assume there's a 1 right over here. Okay? And now we can't leave the coefficients out. We have to take them into account. So 1 plus 1 becomes 2. And therefore, the square root of 13 plus square root of 13 is equal to 2 square root of 13. You see that? This is how you add a radical as long as they have like terms, same number. Let me show you another example. Let's try with a coefficient. How about 5 square root of 24 minus, how about 4 square root of 24? Again, first thing you have to do is check the numbers inside the square root. Are they same? Are they like terms? Yes, they are. These are definitely like terms because both the numbers are exactly the same, which means math is possible, and that means my final answer will definitely have radical 24 in it. Okay? Next step, take a look at the coefficients, the numbers outside of the square root, the 5 and the 4. We need to take them into account, so 5 minus 4 becomes 1. And final answer is just the square root of 24. You don't have to write the 1 in front, it's already assumed to be in there, okay? If you want to put it, you can, but it doesn't really matter. You see that? Like terms, it really matters when you're adding and subtracting radicals. Now let me show you an example like this. The square root, let's do minus 9, square root of, I don't know, 56 minus, 3 square root of 12. Now, take a look at this. Again, start with the numbers inside of the square root. Are they the same? They're not. They're different. This is 56 and this is 12. They're not the same numbers. They're not like terms. That means we cannot do anything to this problem. You cannot subtract it. You have two completely different terms, two completely different square roots. So, in terms of my final answer, whatever this question is, the answer is going to be exactly the same number. Minus 9 square root of 56 minus 3 radical 12. I can't do anything to it. I can't change anything, so I have to leave the answer exactly the way it is. Now you're probably wondering, well, Mr. Mehta, what about these coefficients? Can we do something with the coefficients? No, nothing can be done with them. Because as long as the terms don't match, the coefficients don't matter. They don't help. They don't do anything for us. Okay? So what ultimately matters is that you have like terms. The numbers inside a square root have to be the same. Then only you can add or subtract a radical. And one thing I must mention, of course, is that if you have a square root or a radical with a number, like for example, like this, when you do your math and you come across an answer like that, don't stop over there. This is a perfect square root. Keep going. Square root of 9 can be solved as 3. You see that? You keep going. Don't stop. If it's a perfect square root, keep solving it until you get a final answer. If you stop over here, it's not good enough. Okay? You got to keep going on. If you have a square root like this where there is no answer, it is not perfect, then you can leave it like this. This is fine. But this is not fine. You got to keep going on. Okay? This is how you add and subtract basic radicals. Thank you.